Very nice. Now it's time for the example which is connected with the interval series. And here we have the well-known task which tells about the COVID-19 death distribution of age in Italy and Spain. And we consider the interval series in which we have 1, 2, 3, 4, 5, 6, 7 classes of age. Here we have the values of our variable. We can name the variable using the symbol of xi. This is the age of COVID victims expressed in years. We distinguish 7 classes, 7 intervals of age of COVID-19 victims. And here we have two populations, P1 and P2. Here we have the age distribution of COVID-19 victims in Italy, and here we have the distribution of age which characterizes the population of COVID-19 victims in Spain. So we have one variable and two different populations: Italian COVID-19 victims and Spanish COVID-19 victims. And our task is to, on the basis of the real statistics, estimate and interpret standard deviation and coefficient of variation. Yes, and coefficient of variation in this population in respect of age of the COVID-19 victims. In other words, we are trying to prejudge, trying to determine which population is more differentiated in respect, in point of view of age. Italian COVID-19 victims or Spanish COVID-19 victims. This is our main goal. Yeah? Okay. In the first step, we should compute variance. Let's assume that my main point, my main subject of interest are Italian COVID-19 victims. Yeah, so for a while, Spanish COVID victims don't interest me. Okay, I'm dealing with the Italian victims only. Okay, so in the first step, we need, of course, the reference point, the mean value of age of COVID-19 victims. Yeah? The average. So we need x mean of the average age of Italian COVID-19 victims. As you remember, this is the sum from I equal 1 up to k. K is the number of the classes. We have 7 classes, so here we have the sum from I equal 1 up to 7. And in the bracket we have what? We have xi with a circle which mean this xi with a circles mean the middle of the classes multiplied by relative frequencies. Yeah. And if we sum up these products, we will receive the average age of Italian COVID-19 victims. Yeah, but of course, I have repeated this many times, so I don't want to show you this once again. Please trust me or check it out at home. The average age of COVID-19 victims in Italy is about 80.2832 years. I want to be very accurate, so here I have mentioned 4 places after a dot. As you can see here, we have also 4 places after a dot. This is the consequence of the fact that, as you know, the youngest people, the youths, tend to undergo COVID-19 asymptomatically. Yeah, they are rather carriers of the virus, and they don't die often due to COVID. So the percentage of the youngest deaths, yes, in the total number of deaths of COVID-19 victims is relatively small. So we should be here very accurate, because here we are approaching to 0%. Yes, we are approaching to 0%. Okay. The variance. The variance. We need the formula for variance. As you remember, we have both versions of the formula for variance. The first version is using, of course, the relative frequencies, is the sum from I equal 1 up to k is equal to 7, of what? Here we have the deviations. The deviations of the middle of the classes from the mean. Yeah? And these deviations are squared and multiplied by the relative frequencies, the weights. Yeah? Okay, but we know also the alternative formula, in which we have the sum from I equal 1 up to 7 of squared middle of the classes multiplied by relative frequencies. And here we have, after minus sign, we have squared average value of age of COVID-19 victim. My experience indicates that this version of the formula is more convenient, more effective. Yes, we need a less number of the columns here, so I will use this version of the formula, in which we have what? This is the middle of the class. Yeah, I need the column with the middle of the class. The middle of the class is actually, because I'm talking about the 7 classes. And the middle of the class is 9.5, 29.5, 49.5, 64.5, 74.5, 84.5, and 98.5. Yes, I forgot that the oldest victim in Italy and in Spain, both in Italy and Spain, was 107 years old. Okay, I have the middle of the classes. First step in the computation of the variance is to raise the middle of the classes to the power of 2. So here I have squared middle of the classes. Squared middle of the classes. And squared middle of the classes are following. 90.25. This is 9.5 squared. After that I have 870.25. This is 29.5 squared. Okay, and after that I have 2,450.25, 4,160.25, 5,550.25, 7,140.25, and 9,702.25. Yeah, this is the column of squared middle of the classes. Okay, and in the next step, as you can see, we are going outside this formula. Yes, this is our starting point, and after that I have the product. The product between what? Between the middle of the classes and the relative frequencies. So here I construct another column in which I have squared middle of the classes multiplied by relative frequencies. So in the first row I multiply 90.25 multiplied by 0.0001. This by this gives us 0.009. In the next row I have the product of 870.25 multiplied by 0.0024, and the result is 2.089. And the next product is 2,450.25 multiplied by 0.0443, and the final result is 108.546, and we have the next values 162, 525.774, 2,916.078. Please check it out. 1,603.782. Yeah, we have all the products. After that, I need to sum up that column. Yeah, I need to sum up that column, and the sum of that column according to Excel according to Excel computations, so be careful here. According to Excel, the sum of these products is 6,591.43. Yeah? All right. So now we have the partial results, and we are able to compute the variance of age of Italian COVID-19 victims. So here we have 6,591.43 minus squared value of 80.2832 squared. Yeah? And the final result is 6,591.43 minus 18.2832 squared. And the final result is 146.0378 years squared. Yeah, years squared. The unit years squared has no interpretation. Yeah, so we need to compute standard deviation. Yeah, standard deviation. I need more space. I can delete this content. This is the variance of age of Italian COVID-19 victims. And now I am able to compute average deviation of Italian COVID-19 victims' age. Yes? Average deviation of age, actually, of Italian COVID-19 victims. This is the root of variance. Yeah? Here I have the suffix IT, which indicates Italy. So the final result is 12.0846 years. Yeah? Okay, we are able to interpret the standard deviation of age of COVID-19 victims in Italy. So the interpretation is following. In Italy, COVID-19 victims are characterized by the average age deviation from the mean equal to approximately 12 years. Yeah, this is the interpretation of the measure of dispersion. So in Italy, COVID-19 victims are characterized by the average age deviation from the mean equal to approximately 12 years. We know the typical level of considered phenomenon. The average age of COVID-19 victims in Italy, and we know what? We know the average age deviation, yeah, of COVID-19 victims. So we can compare these amounts with appropriate amounts constructed on the basis on the data connected with the Spanish victims. So we can compare the results. Here. Let's make a comparison of age of COVID-19 victims in Italy and Spain. Here we have the average age of COVID-19 victims in Italy and Spain. Here we have the average age deviation of COVID-19 victims in Italy and Spain. And now, as you remember, we have one variable, we have two populations, Italian victims, Spanish victims, and we have to answer the question which population is more differentiated in point of view of age. Spanish COVID-19 victims or Italian COVID-19 victims. And for this purpose, we need to compute coefficient of variation. Yes, we have the same variable, yes, so the unit of the variable is the same in both populations. But here we have a little difference between the mean level, average level of considered phenomenon. So it's safe to compute coefficient of variation in order to keep calm, yeah. And the final results are following. Here we have coefficient of variation equal to 1.51, of course 0.151, and here we have 0.155. Yeah, so as you can see, both populations are similarly differentiated in respect of age. Yes, both populations, Italian and Spanish COVID-19 victims, are differentiated. Yeah, the value of the values of age are differentiated in the similar degree. Yeah, in the similar degree in both populations. Yeah. So here goes the main remark that these populations, in respect of death distribution due to COVID-19, are very similar to each other. Yes, we have similar level of average age of COVID-19 victims in both populations. We have similar differentiation of the age of COVID-19 victims in both populations. Yes, so we can say we are 100% sure that these populations are similar to each other in respect of the age of COVID-19 victims. And the second remark is, here we have about 80, 81, yes, in both populations, average age of COVID-19 victims. And we also know that here we have, for example, these values are similar to 12.5, yeah. So here we have the group, we have indicated the group of people which are most at risk of death due to COVID-19, yeah. So this is the average value plus and minus standard deviation, yeah, plus and minus standard deviation, for example 12.5, yes, because I'm trying to combine two results together, yeah, to have one conclusion. So the most dangerous endangered group, yes, the group most at risk of death due to COVID are people aged from 81 minus 12.5, 68.5, and 93.5. Yes, in here the main conclusion, I have combined two results together. Here we have the group, yes, in which we have the most number of deaths due to COVID-19. So this group is the group most at risk due to COVID-19 disease. Alright then, we can solve the next task, task 3, in which we have one business consulting company checked the total number of customers served by each employee per day. The results were following. And as you can see, we have the information gathered in the table. Here we have the interval, a series of total number of customers served. This is our xi variable. Let's assume that the symbol of the variable is xi. Here we have 4 classes of total number of customers served per day, and here we have the information about the workers. Cumulative frequency here answers the question how many workers are characterized by the total number of customers served not higher than the upper bound of a particular class. So this situation is different than the previous one, because here we perform on the frequencies. Yeah, earlier we had the relative frequencies. For this reason, we will use another group of the formulas which are strongly associated with the frequencies. And our task is to calculate and interpret standard deviation and coefficient of variation. Firstly, if we want to compute standard deviation, we must compute the variance first. Here variance of the variable x values is given by the formula. Here we have the frequencies. Of course, at the moment we have cumulative frequency, but we have to decumulate this column. Here we have NIS, and I'm going to decumulate this column in order to obtain the clear frequencies here. So the variance is given by the formula here. The sum from I equal 1 up to k, we have k classes. In our example, we have 4 classes, yeah? So here we have the sum from I equal 1 up to 4 of the deviations. The deviations of the middle of the classes from the mean, and these deviations are squared. Okay, and we divide the sum by the population size, which is 52 employees. Yeah, the last cumulative frequency, as you remember, is the population size. Okay, but as you remember, here I am able to use the transformed version of my formula for variance, which is the sum from I equal 1 up to n of squared the middle of the classes multiplied by ni's divided by n minus mean value squared. This is the alternative formula for variance. Of course, I can use this formula in the computation or this version of the formula. Yeah, the results will be obviously the same, but as I said before, in my opinion, this version of the formula is more convenient, more effective in the calculation, so I will use this version of the formula. Okay, let's look inside the formula. What I need what? Of course, the middle of the classes. Yeah, so I need the column with the middle of the classes. Of course, I need the column squared middle of the classes, squared middle of the classes, and finally, at the last stage, I need the product of squared middle of the classes and the frequencies. Squared middle of the classes multiplied by the frequencies. Okay, let's start calculation. Let's start the calculations. Of course, here we have cumulative frequency. First frequency is equal to first cumulative frequency. And here we have actually the increase, the difference between a particular cumulative frequency and the previous one cumulative frequency. Yeah, so 21 minus 3, it's 18. Yeah, 3 plus 18 is 21. And after that we have the difference between 48 and 21. This difference is equal to 27. And at the end, the difference between the last and the third cumulative frequency is 4. Yeah, and I have decumulated the column of cumulative frequency. So next values of the frequency are the difference, yes, the increase or the difference between next cumulative frequencies, next two cumulative frequencies. Okay, and now I need the middle of the classes. As you remember, the middle of the class is the arithmetic mean between lower and upper bound of each class. So here we have 5, here we have 15.5, here we have 25.5, and of course 35.5. And now I'm going to raise this middle of the classes to the power of 2. I want to compute square of the middle of the classes. Square of the middle of the classes, of course, 25, 240.25, 600, 500, 650, sorry, 25, and 1260.25. Alright, and in the last step I'm going to compute the products between the middle of the square, the middle of the classes, and the frequencies. So 25 multiplied by 3 gives us 75. After that we have the product of 240.25 and 18. Yeah, 240.25 multiply times 18 by 18 is 4,324.5, and so on. The next results are following: 17,556.75 and 5,041. Yeah? Alright. Okay, let's remind yourself the formula for variance. The sum from I equal 1 up to 4 squared middle of the classes multiplied by n i's divided by n minus squared arithmetic mean. Okay, I need the what? I need the sum of the products. The sum of the products are following: 75 plus 4,324.5 plus 17,556.75 plus 5,041. Okay, I have a partial result to 26,997.25. Okay, but I have noticed that I don't have the arithmetic mean of total number of customers served, so I must compute it. Yeah, because I have only one partial result here. I don't have any information about the mean, so it's very easy to compute the arithmetic mean here. of total number of customers served. I have done it many times. As you remember, we multiply, in order to compute arithmetic mean, we need the sum from I equal 1 up to 4 of the products between the middle of the classes and the frequencies divided by n. So here we multiply the middle of the classes by the frequencies. So we are going to multiply the values from this and that column. Yeah? First we have 5 by 3, 15. Yeah? After that I have 18 multiplied by 15 and a half, 279. Next we have 25 and a half multiplied by 27, 688.5. And here we have 4 by 35.5, 142. 142 plus 688.5 plus 279 plus 15 is, ladies and gentlemen, 11,000, sorry, not 11,000, 1,124.5. Yes, this is the, I need a summary line. Yeah, summary line. Here we have the sum of this kind of products. Yeah, so now I am able to compute the arithmetic mean of total number of customers served, the average number of total customers served by workers of one business consulting company, which is 1,124.5 divided by the population size. As I said before, the population size is 52. So I divide the sum by 52, and here I have 21.625 persons per day. Yeah, this is the average number of total customers served in one business consulting company. Yes, total number of customers served by employees of one business consulting company. The average number, the mean number of customers served is around 22 persons per day. Yes, it's around 22 persons per day. Okay, so currently I have all the partial results I need. Yeah, I have the sum of the products of squared middle of the classes and the frequencies, and I have computed here the mean value of total number of customers served. So variance here yields to 26,997.25 divided by how many? By the population size 52 minus the arithmetic mean 1.625 squared, of course. And here here will be given to you the value of the variance 26997.25 divided by 52 minus 21.625 squared, and ta-da! The variance is equal to 51.5537 approximately, of course. Persons per day or customers per day squared, of course. It has no interpretation, so I am obligated to compute the standard deviation, which is the root of variance. So we compute here the root of 51.537, yeah, and the final result is 7.179 around, yeah. Approximation, 3 places after a dot. Persons per day. This is our standard deviation. Of course, before the interpretation, now I am able to compute coefficient of variation. Maybe here I have a lack of space, but okay, I will make it. Coefficient of variation based on the standard deviation here is standard deviation divided by arithmetic mean. Standard deviation of total number of customers served divided by the average number of customers served. In our example, we have 7.179 divided by 21.625. 21.625. 7.179 divided by 21.625 is around 0.331. Yeah, 0.331. So it's around 33%. One thirds. Yeah, 1/3. Okay, and now it's the right time to make some interpretations of computed measures. Interpretation of the measures is just as important as the calculations, and therefore standard deviation of total number of customers served is around 7.179 persons per day. What does it mean? Please write it down. It means that total number of customers served deviate from the mean on average, because we are talking about the average deviation from the mean, on average by approximately 7 persons per day. This is the interpretation of the standard deviation. And as you can see here, we have the average level of considered phenomenon, total number of customers served, and the average deviation from the mean is about 7 persons per day. This is the average deviation. And here we know that this average deviation represents 33% of the mean. Yeah? So we can write it down. Average deviation of total number of customers served is 33% of the mean. Okay, as you remember, some statisticians proposed the following interpretation of that amount. Yeah, here 33% is the second interval of coefficient of variation in the example of the interpretation. So here we have we are talking about moderate variability of variables values. Yeah, moderate variability of. Here we talk about the moderate variability of total number of customers served. Moderate variability of the values of total number of customers served. Okay. And finally, we have point B. If we know that coefficient of variation for the employee bonuses, let's use here the symbol of the variable yi. Employee bonuses is coefficient of variation of this variable is equal to coefficient of variation of the values of this variable is equal to 0.133. Please answer the question. Is this population employees of one business consulting company? Is this population more differentiated in point of view of total number of customers served or the employee bonuses values? The employee bonuses values. And of course we see that the module of VSX is higher than the module of VSY. Yeah, so this population, the concluding remark, this population or the employees are, or the employees sounds better, the employees are more diverse, differentiated, varied in point of view of, or due to, yes, shorter, due to of course number of customers served. Yeah. So in this situation, we talk about the one population which is characterized by two variables, two features, two attributes. Total number of customers served and the employee bonuses. And we know that this population is more differentiated in point of view of the total number of customers served. Yeah. So the members of this population, the employees, are more similar to each other in respect of the employee bonuses, more similar of each other. Here, more differentiated. Yeah, more similar, more differentiated in respect of total number of customers served. Okay, earlier we have the situation when we talk about two populations. Yes, the population of Italian and Spanish COVID victims, and we had one variable, age of COVID-19 victims. Yeah. All right.